Power factor. What is power factor? Power factor is a measure of the efficiency of an AC circuit. There are three types of power in relation to a circuit. True power, the actual amount of power being used or dissipated in the circuit and is measured in watts. Reactive power, inductors and capacitors drop voltage and draw current, implies they dissipate power. This phantom power is called reactive power and is measured in a unit called voltamps reactive. And apparent power, the combination of reactive power and true power is called apparent power and is the product of a circuit's voltage and current without reference to phase angle and is measured in the unit of voltamps. This beer analogy shows the difference between the useful power, the reactive wasted power, and the demand apparent power. The power triangle. Total power or real power is proportional to the circuit's resistance. It is the useful power. Reactive power is a proportion of the electrical power that does not perform useful work but is necessary to maintain the voltage levels and magnetic fields in the circuit, and is associated with the energy stored and released by reactive components. The reactive power is proportional to the circuit's reactance. Apparent power is the vector sum of real power and reactive power. It represents the total power in an AC circuit, combining both the active and reactive components. Apparent power can be calculated similar to total and reactive, however proportional to the circuit's total impedance, or also can be calculated with P equals IV. The triangle displays a relationship between the different types of power and how the power factor is the ratio of true to apparent power. This is equal to the cosine of the angle identified, which happens to be the same angle as impedance phase. Hence, power factor can be calculated if the impedance of the circuit is known. In resistive circuits, the power factor is 1, and the power waveform is entirely positive because the reactive power equals 0. In cases where the power factor is less than 1, it means the circuit's wiring has to carry more current than that would be necessary with zero reactance in the circuit to deliver the same amount of power to the resistive load. In an inductive circuit, the current lags the voltage, resulting in a lagging power factor. Conversely, in a capacitive circuit, the current leads the voltage, producing a leading power factor. A poor power factor can be corrected by adding either inductive or capacitive load in the circuit. Suppose a motor draws 10 amps at 240 volts with a power factor of 0.7 lagging. This means 1680 watts is doing useful work while the remaining power is wasted in reactive effects. If the power factor is corrected to 1 using capacitors, the current demand drops to 7 amps, reducing the line current by 30%, which lowers heating losses and improves efficiency. Power factor correction is widely used in industrial plants, where large inductive loads cause lagging power factors. By adding capacitive components, these facilities improve their power factor close to unity, reducing energy losses, avoiding utility penalties, and increasing equipment lifespan.